Okay, welcome everyone to today's webinar. My name is Sylvan Kaufman. I represent the Chesapeake Conservation Landscaping Council and will be moderating today's webinar. I want to welcome everyone to Urban Tree Selection in a Changing Climate with Dr. Bert Cregg. This is one of many webinars that we're offering this year in a series called A Focus on Sustainability. This series was developed in 2013 by a group of organizations known regionally in the United States for their quality education programs for professionals in the landscaping industries and landscape design. We're working together to expand the reach of these education programs through our webinar series. If you're not familiar with the organizations, they're all nonprofit and largely volunteer. They're the Ecological Landscape Alliance, ELA, in the northeastern United States, the Chesapeake Conservation Landscaping Council, CCLC, in the Chesapeake Bay region, and Eco Landscapes California. So I just want to introduce Dr. Cregg. He's an associate professor and extension specialist for landscape nursery and Christmas tree production at Michigan State University. His expertise includes stress physiology, plant nutrition, and plant response to environmental stresses. Dr. Cregg writes frequently on landscape and nursery topics and is a regular contributor to the MSU Extension News, Michigan Landscape Magazine, and the Great Lake Christmas Tree Journal. Prior to joining MSU in 1999, Dr. Cregg was a tree physiology project leader for International Paper and a research plant physiologist of the USDA Forest Service. He earned his PhD in forest resources at the University of Georgia and holds a Master of Science in Forestry from Oklahoma State University and a Bachelor of Science in Forest Management from Washington State University. So it's my pleasure to welcome Dr. Cregg for today's very timely webinar, given some of the weather that we've been experiencing in at least the eastern and other parts of the United States. So, Dr. Cregg.
Okay, I'm ready to go,
okay.
And I will try showing my screen and getting in presentation mode. Are we seeing that, Sylvan?
Yes, it looks good.
All right, great. All right. Well, thanks everyone for tuning in this afternoon. As Sylvan mentioned, if you're certainly anywhere in the eastern half of the U.S. right now, you're probably experiencing a day that's maybe 15 or 20 degrees warmer than what you would normally expect this time of year. I'm here in East Lansing, Michigan, and right now outside my door it's about 75 degrees, which makes me not want to be in front of my computer, but we're doing what we have to do here, and I'll get out there later on yet today. But certainly a timely topic, and I think something that for everyone who's involved with trees in landscapes in any form or fashion, as a designer, as a nursery person, as a landscape installer, arborist, whatever your role in dealing with trees in urban and community forests, the subject of climate change is certainly something that has everyone's attention these days, and not just because it's so warm out today. So let me just kind of talk about what we'll go through today. And as Sylvan mentioned, I'll try to take a couple of pauses along the way, and if there are questions that come up in the chat box, we can address those. We'll also leave some time, hopefully at the end, to address some additional questions that come up along the way. A lot to cover, and I may move quickly, so if I do get ahead of folks, just let me know, and we'll try to pull things back as we go along.
Dr. Cregg,
I'm here in, yeah.
Sorry, let me just interrupt for a minute. For some reason, only the left portion of your slide is showing.
Oh my.
And so I'm thinking that either you could go out of presentation mode or
Okay. Let me go out and go back in. How's that? Let me try that. Any better?
It's still the same problem, unfortunately. We can see the slide outside of presentation mode, although you won't be able to.
Well, that's fine. I can expand that maybe, and
yeah.
we'll be creative here, whatever we have to do. That means you'll get a preview of what's coming at you. That's all right. Yeah, I don't have a whole lot of animation or things like that, so that shouldn't be a major.
Okay. Actually, try one more time to put it in slideshow.
Okay.
I'm just thinking that maybe because your screen was reduced, that might have made a difference. Okay. Okay. I can now see all of it. Thanks.
Oh. Okay, well, if we try enough times here, we'll get it right. Okay, so the idea here is I'm in East Lansing, so some of this will be a bit Midwest focused, but I think most of the kinds of things that we'll talk about in terms of projections and things that are going on in terms of climate change will certainly apply throughout the northeastern U.S. and probably even out west as well. So kind of review some of the things that we're looking at and what's coming at us and why are we seeing the things that are going on in terms of some of our climate and weather patterns. We'll specifically talk a little bit about urban trees, and in some ways we can think of trees in cities when we discuss climate change as sort of the canaries in the coal mine, and I'll talk about why that's the case and why we need to be concerned about trees in urban areas and what are the potential impacts. Okay, how are climate change, or how is climate change going to impact trees in our cities? And you know, most of it's probably not going to be good, and we'll talk about that. My audio okay?
Yes, you sound great.
Okay. I got a little note there, so my audio was off for a second. Okay, and then of course what we're talking about here is tree selection. So this is a very complex topic, and I'm going to throw a little bit of physiology in here and so forth, and hopefully that won't cause anyone any discomfort. But when we think about how trees are going to respond to the various changes that are forecast, very quickly it becomes a very cloudy picture. And part of that is because climate change is not necessarily something that's going to be unidirectional. In other words, it's not simply going to be getting warmer and warmer. It will over the long term, but sort of like our stock portfolios, you know, it doesn't always move in one direction, and that's something we need to be thinking about as we go along here. And then hopefully towards the end we'll pull all this together and give people some things to think about and take home. So with that, let's go ahead and jump in, and certainly climate change is nothing new to most of the folks, I'm sure, that are partaking in this webinar today. It's you know, anytime you turn on the TV or magazines or anything, the internet, you know, political campaigns, we're talking about climate change and what can we do about it, and all of this of course goes back to industrial revolution times in terms of our impact, man's impact on our atmosphere and our climate. And we've seen since the dawn of the industrial age in the late 1800s, first of course we were driven largely by coal as we were in the dawn of the industrial age, and then as we got into the middle to latter part of the 20th century, then of course gasoline and oil became much more in use in terms of transportation fuel, and so we see this net increase over time that we've had of global carbon emissions. So we've been taking carbon that was stored in the ground and fossil fuels, and now we're getting that carbon out into the atmosphere. And one of the most dramatic things I think we can look at is this data here from Mauna Loa, which is the observatory that NOAA, the National Oceanic Atmospheric Administration, maintains in Hawaii, and the idea is out there in Mauna Loa, it's far removed from any direct influence of immediate cities or things like that, so it gives us sort of a pristine or sort of baseline read on what our global atmosphere, or at least that part of the global atmosphere, is doing. And so what we're looking at here is basically my lifetime. I was born in 1959, so maybe I'm the cause of all of this, I'm not sure. But if we go back here to 1959, we were looking at a global CO2 level of about 310 parts per million. So in my lifetime at least, what we have seen is this continual ramping up of global CO2 based on the combustion of fossil fuels, to where now our average global CO2 is right around just a little over 400 parts per million. So a dramatic increase, over 90 parts per million from a baseline of 310 less than 60 years ago. And so this is something that certainly is cause for concern, and is going to have pronounced impacts on our global climate. So if we look at this, we've gone from the pre-industrial times. My slide is a couple years old here. I didn't realize I hadn't updated it. We're now over 400. We say 395. It's actually over 400 parts per million. And based on current trends, we'll be looking at about 700 parts per million of CO2 by 2050. This has implications both in terms of plants directly, because of course plants are using CO2 for photosynthesis to make sugars and through the process of photosynthesis, but also of course because CO2 in the lower atmosphere is a greenhouse gas that is going to trap heat and result in increasing temperatures. And some of this we're already seeing. So this is data from NASA. This is looking at temperature anomalies. So if we look at this particular slide, happens to be from the average temperature of 2008 to 2012 relative to the previous 40-year average. And you see that for most of certainly the northern hemisphere and even most of the southern hemisphere, we're at least 1 to 2 degrees warmer in Celsius than we were in the previous 4 decades. So certainly the trends are there, and we're seeing this increase. And just a few more things. Again, I'm not here to convince anyone of what's happening with the atmosphere. Certainly we know what's going on with CO2. That's undeniable. That's hard data. What we've seen so far in terms of temperature trends certainly is there. And then when we look at things like extent of Arctic sea ice, the trend here is clear as well. If you go to Glacier National Park, if you want to see the glaciers there, you probably better hurry. Probably got a few more, maybe 10 or 15 more years before those will be gone. So clearly we've got some things going on. In terms of the central U.S., and a lot of this will apply again to the Northeast and other parts of the U.S. as well, but certainly one of the things we've seen in addition to this overall warming is we're getting warmer winters and often warmer minimum temperatures, and we'll talk a bit more about this, and everybody's raising their hands, and what about the polar vortex, and we'll talk about that. Certainly seeing increased humidity, summer dew points, and again a lot of this is increased evaporation. Also we are seeing in many areas greater annual precipitation, and often in terms of more winter snowfall. Here in the Great Lakes region, we just are having predictions because of the very warm summer and fall that we've had that the Great Lakes will stay warmer longer. That for us means more lake effect snow, so we've got good potential for increased snowfall here, and then more intense and frequent summer rainstorms. So that's why sometimes you hear these predictions of warmer, drier, warmer, wetter, and sometimes that can depend a little bit on which part of the country you happen to be in. The forecast looking ahead, this is IPCC, if you're not familiar, is the Intergovernmental Panel on Climate Change. They are sort of the overarching body that is tracking and making the predictions on what's going on with climate. And so they run a whole series of models, and I'm not a climate scientist and won't pretend to know all the nuances of everything that goes into those. But when you look at either sort of a business as usual model there in the orange, based on our current trends, versus the blue would be if we were able to stop increases in carbon emissions or keep them from going up any further than they are right now, what would happen to climate. So some of this is already pre-programmed in. Even if we were able to stop increases in CO2 emissions tomorrow, it's sort of like turning a battleship. It takes some time, and there's a lot of momentum in the system. But the sort of worst case scenarios here, you're looking at additional temperature increases of around 4 degrees Celsius by the end of the century, perhaps as high as 5 degrees. So these are pretty significant shifts when you look at these in terms of average global temperatures, and certainly something that's going to affect plants. One way to look at this, and I think is helpful, at least it was for me, because when you hear these projections, and again you hear this in news reports, you watch Nova or you watch whatever, and they start throwing these numbers around. First of all, I have trouble thinking in Celsius, so that's one thing. But what does that really mean? And so this was an interesting paper, and what they did was to look at, for various states around the country, if you take the projections in what is going to happen to temperature, what is going to happen to rainfall, and take those, and if we say it's going to be 2 degrees warmer and 20% drier, or whatever the scenario might be, what's the current location that has that set of conditions? So for Michigan, if we look at this, and if we look at, and we'll keep it simple here, we'll look at the red images there, that's looking at the higher emission scenario. So we don't cap our carbon emissions, we continue to increase in a manner as we have. What is going to happen to our temperature? Well, if we look at where we sit today here in Michigan, that means by the middle of the next century, or actually this century, sorry, by 2040 to 2050, our climate here in Michigan would look like that of roughly Iowa and southern Illinois. Okay, and by the time we get to the end of this century, 2080 to 2099, our climate here in Michigan would be roughly that of present-day Oklahoma. Okay, to kind of put things in perspective. And so when we're thinking about this in terms of tree selection, well, if I'm planting trees today, how long do I expect those trees to be around? Well, we know there's limitations, obviously, with the lifespans of trees in urban areas, but one would hope that, a tree I plant today might be around in 50, 60 years. So, we're looking at a pronounced change in the environment that tree might see by the end of its lifetime compared to what we're currently looking at and what we might have originally selected that tree to have to withstand. We tend to focus on the increase in temperature, and we talk about becoming as warm as Oklahoma. But one of the things we've already seen is that when we look at the changes in temperature that have already occurred here over the last, say, 30 to 40 years, a lot of what we're seeing is mainly increases in minimum temperatures, so nighttime temperatures and wintertime temperatures. And this was an article, apologize, I've forgotten the journal it was in, but it was basically looking at minimum temperatures, which is what we base plant hardiness zones on, right? And so the basic conclusion of this author was that hardiness zones are essentially going to be obsolete. In other words, winter temperatures are going to be increasing at a rate faster than we can actually keep up in terms of trying to produce these color-coded maps and all things that we have for hardiness zones. I think that's one view, but certainly there's some data out there to support it. But we'll get back to this. Well, we'll get to it right now. The other side of this, of course, this was 2012, so he wrote this before we experienced the winters of 2014 and 2015, right? And so we know that even though our temperature trends are generally heading upward, as I mentioned, it's sort of like the stock portfolio. It's not all heading in one direction. And in fact, part of the predictions that are embedded in those IPCC models is that not only are we going to see general increases in temperatures, but also more variable weather patterns. And so that's part of the challenge in all of this. If it were simply a matter of next year is going to be warmer than this year, we can begin to anticipate that. But the problem is we still have these winters that will come up as we had with these polar vortex events. Just walk you through this slide very quickly. This is data that I had readily at hand. This is from our weather station here at the MSU Horticulture Farm. And so we have a data logging system out there. I can access it from my computer, and it keeps track of daily high-low temperatures, precipitation, all of that sort of thing. And so what we're looking at here is the number of days in each year, so starting in 96, which was as far back as the records went, starting in 96 going through last year, how many days did we get below -10? And so our hardiness zone here, we're in zone 5B. So our hardiness zone would say that on average we should get down between -10 and -15. That's kind of our average year. That's what the hardiness zone represents. How cold, on average, what's the coldest temperature you're going to see in a given year? Well, we went a lot of years. If you look at these gaps in here, there are a lot of years where we never got down to our hardiness zones. And so, again, this notion that we were in a generally warming trend, especially in terms of wintertime temperatures, and then, of course, we hit 2014 and 2015, which were our polar vortex, different terms that people use to describe them. But basically, we had more nights below our hardiness zone, or at least in our hardiness zone, or colder. So in 2015, we actually had 5 days that were colder than our hardiness zone. We got down to -23 here a couple nights in East Lansing in February 2015. And so, yes, in general, we're warming, but the challenge is, trees don't respond to the averages. Trees respond to the extremes. And so there were lots of trees that were planted in these intervening years where we didn't have temperatures colder than our hardiness zone that were maybe 12 or 15 years old. They got taken out during these 2 winters. And so it's going to be a real challenge for us as we move forward, is how do we find trees that can withstand these higher temperatures overall, but yet still going to be cold hardy enough to withstand that occasional year, right? It only takes that 1 in 20, in this case 2 in 20 years, to cause a lot of havoc. And then, of course, we're talking about urban trees, and things become even more complicated because we have to deal with the urban heat island effect. So most of you are probably familiar with the notion that if you are in a downtown area, and we're looking at temperatures, this happens to be in Celsius again, but if you're looking at temperatures in the downtown area, we're probably looking at temperatures that are going to be 4 to 5, maybe even 10 degrees Celsius warmer than if you were in the surrounding countryside. It's the old thing about, why did they take the temperature out the airport? Nobody lives there, but because you're getting away from all of the buildings' re-radiated heat coming off of buildings, asphalt, and all of that. And so, but for trees that we want to plant in these areas, obviously they're going to have to deal with those conditions, as well as to the overall warming that we're going to be experiencing. And so that's why I say in many ways we can think of urban trees as the canary in the coal mine. So in many ways they're already experiencing some of these extremes, right? They've been living with temperatures that are 3 or 4 or 5 degrees Celsius warmer than the surrounding areas already, and then when we superimpose this general warming on top of that, along with restricted planting volumes, all of the things that we throw onto trees in urban areas, it becomes a real stressful situation, and in some ways, the guinea pigs for climate change, if you will. In Sylvan's introduction, she mentioned that I used to be with the Forest Service, and this is actually some work I did back then. This is in Lincoln, Nebraska, so I was with the USDA Forest Service Research Lab out of Lincoln, Nebraska. They do have a Forest Service lab in Lincoln, Nebraska, yes. And so in this case, what we were looking at was some of the water relations and stress responses of trees in urban areas. We actually compared trees. We looked at the same species grown in this downtown area, downtown Lincoln, Nebraska, versus what was going on in a relatively park-like condition over on the campus. And so one of the things we did when we did this project was to actually put portable data loggers. You may be familiar nowadays, you can buy these. They're called Hobo, or there's a couple different models out there, but they're little portable self-contained data loggers. You launch them with the laptop and then you can leave them. They're waterproof and everything, and then you can come back later and collect the data off of them. Pretty handy. And so using these, we had these Hobo data loggers up in the canopies of these trees, so we could record what the canopy temperatures were in these different locations. So we had the campus location, kind of a park condition, versus our downtown area. Oops, skipped ahead one here. And so if you look at this, we're looking at what was going on. Here's our temperature. This is in Celsius here. Looking at, on a given date, this was in July of the particular year we were working on, and I think July 7th, I forget the exact date, but here's the official high temperature, Lincoln Weather Service office, this one point here. That was the official high temperature for the day, occurred about 4 o'clock in the afternoon out at the airport. And what was going on our campus location. Okay, so again, this is kind of a park-like area on the University of Nebraska campus. And then what were those trees experiencing downtown? So again, if you're like me and have trouble thinking in Celsius, I'll go ahead and make the conversion. So on a day when it was 108 at the airport, in the campus tree canopy, there are some roads, and so there is some reflected heat there. The canopy temperature would have been 117. Downtown, the trees were experiencing 126 degrees Fahrenheit. So when we think about tree selection, you know, where do we find trees that can adapt to 126 degrees? Well, it's a challenge, and especially in an area like Nebraska, where there aren't many native trees to choose from to begin with, it really makes it a challenge to look at. One of the things I like to point out, and why this is important, is we have to think about how water moves through a tree and what those kind of temperatures do in terms of tree stress. So high temperatures directly can cause issues for trees. There are things that happen to trees at extremely high temperatures. Those usually have to be extremely high to cause significant damage, things like denaturation of proteins and membrane breakdown, all those kind of things. But what does happen rapidly as temperature increases is the amount of water that a tree is going to use. And so I use this graph here quite a bit in lectures, and it's this notion of the soil-plant atmosphere continuum. So the idea that, you know, this is a little seedling here, but the old thing of how does water get to the top of a 300-foot redwood? Well, it's pulled, it's not pushed, right? So what happens is you have transpiration from the leaves or from the needles, and then as those water molecules are evaporating in the atmosphere, it pulls that water along like links in a chain, and eventually that tension reaches the soil, and that water's pulled in, and it moves all the way through and out into the atmosphere. And that's important because relatively small changes in temperature, you know, a 5 or 10 degree increase in temperature can result in a dramatic increase in water use. And so one of the things that trees are going to face in urban areas is we're going to have these increases in temperatures, increases in potential water use, but at the same time, right, we have restricted root volumes, and so we actually reduce the amount of water available to the tree. So it's going to result in pronounced increases in tree stress. So something we need to be considering when we think about this. The other thing, and probably the more immediate thing that we need to think about in tree selection, and where things get really complex, and I think not all of us, myself included, can always get our minds completely around this, or at least how do we deal with it, and that is the fact that we're going to start dealing with earlier and earlier spring warm-ups. So this is data from NOAA again, and this is from March 2012. And so again, if you lived east of the Rockies, you will remember this March. If you were in California or Oregon, Washington, not so much. But for those of us in the eastern U.S., so the color codes on these maps, this represents there was 118 years of temperature records, okay, that NOAA maintains. And so if your state is in red, that means that March was the warmest March on record. And so you see for that entire, almost all of the eastern U.S., and again anywhere east of the Rockies, it was either the warmest or second or third warmest March on record. Here in East Lansing, we had in the middle of March, third week of March that year, we had a week, solid week, 7 days of temperatures over 80 degrees. And so why is that an issue for plants? Well, things start to move. So this is actually pictures on my place. We normally don't see daffodils till well into April, middle of April or later in our area. Here they are. We've got magnolias in bloom. This is all that same March 19th date, forsythia in bloom. Lovely. Yeah, it's nice. We got students running around campus in shorts and playing frisbee, and life is grand. But all of us that deal with plants knew that basically we were watching a slow motion disaster, right, unfolding in front of us, because it's March. This is not going to last. And sure enough, we got into April. We had a series of hard freeze. We had a 25-degree Fahrenheit night in late April. We had in East Lansing, we had 10 hard frosts that occurred, and so it was a total disaster for our fruit industry. There was no cherry crop at all. So yeah, here's our temperature trend. So that April, after we had that warm up, here we got each arrow here represents a frost event, and with the hardest one actually coming at the end of April. So all these trees were budded out, fruit crops were in bloom, all of that. So it was a major disaster, total disaster for our fruit industry. Cherry crop was completely wiped out, and so now you know, we have political sides in some of these debates, and our fruit tree growers tend to be a pretty conservative lot, but you won't have to do much talking to convince these guys that climate change is something they need to be concerned about, because it's something that certainly hits them very, very directly. And just, you know, things we saw with conifers and other things that went on with that when we begin to deharden, and then we get our hard freezes coming through. So just more illustrations. So questions of, you know, is that simply an aberration, sign of things to come? Probably. I think there's a good indication that this is something we'll have to contend with for some time. So this is a study from Europe. This is actually in France, and what they are looking at is trends in bud break. So they're looking at English oak, Quercus robur, and so they were looking at the period in the 50s up till about the mid-80s, and here's our trend in bud break. So are we breaking bud earlier or later? So red means earlier bud break. Blue means later bud break. So the general trend was, compared to previous periods, either slightly later or maybe on average. Okay. Since that time, and this is looking last 15 years of the last century, there was a consistent trend towards earlier bud break. Okay, so the negative numbers here meaning that we're getting earlier. If you look at a Julian date, what day of the year are we breaking bud? There's a consistent trend that we're breaking bud earlier and earlier. And we're seeing this with lots of things in terms of insect emergence and other things that go along with degree day accumulations that we might have to consider. So certainly something to be concerned with. Just a related kind of look here. This is work that was done with from the Oak Ridge National Lab, where they looked at, again, bud break date, so day of the year. So January 1 would be day 1, and you know, June 1st is whatever day, 160, something like that. They were looking at a series of different species. Big tooth oak, Populus grandentata, Betula allegensis, red oak, Quercus rubra, and then sweet gum, liquid ambar styraciflua. And so what they were looking at is trees that were exposed to ambient temperatures, so just the general temperature of the area, and then they had open top chambers that they could warm the trees. And so here is the temperature enhanced by 2 degrees Celsius, and then enhancing the temperature by 4 degrees Celsius. And then what happens to the bud break? And as most of us would predict, as you increase the temperature, you get an earlier bud break. And so something to think about. But the interesting thing about this, when we combine the bud break date along with bud set, and so now they're looking at the total growing season. So this is days added to the growing season. Again, for our 4 species, the Populus grandentata, Betulaligensis, red oak, sweet gum. And what we're looking at is how much we added to the spring based on the earlier bud break, and then what we add to the fall based on later bud set. So what's our effective growing season? And this is all relative to the control. So we look at warming by 2 degrees, warming by 4 degrees, and as most of us would predict and make sense, the more you increase temperature, the longer the effective growing season. But the interesting thing about this is notice that not all the species respond the same way. So the Populus is certainly the most responsive, or the most plastic, we might say, in terms of its response. The Betula is also increasing. The oak is relatively unresponsive. It does have an increase in terms of growing season based on temperature, but we don't see nearly the response at the warmer temperature that we did with the others. So perhaps this might be an indication this is something that maybe is a more conservative in its response, might be a good choice for our climate change scenarios, less likely to have issues with early or late frost damage if it's not responding quite as readily to changes in temperature. Again, it's very early in this kind of research, so we're just trying to figure out the best ways to interpret these things. Let's talk a little bit about, we've kind of laid out the scenario and what's going on, and what can we really do about it, and that's sort of the next challenge in all of this, is how do we think about trying to manage trees, as we all have to do, in this kind of somewhat certain but also uncertain climate that we're going to have to deal with. And some of this, if we sort of take a step back and think about this in general, ecologists will tell us that organisms have three means to respond to a change in their environment. So if we're thinking about trees, we're thinking about wildebeests in Africa when their watering hole dries up, whatever the case may be, whatever the change's environment is. One is migration. Well, if you're a wildebeest in Africa and your watering hole dries up, obviously your environment has changed and you're going to move. Trees are sessile organisms. Once we plant them, they're not going to move, but we can move them. And so this is one means that perhaps we can respond to climate change, is think about where we distribute trees and how we go about that, and fraught with all kinds of controversies, you might imagine, when we start talking about this, because we may be talking about exotics, we may be talking about all kinds of different things that for some people might be a bit of a challenge. Adaptation. So adaptation, really we're talking about evolutionary change. So the fact that as glaciers recede, plants adapted to new environments, and there were changes, evolutionary changes in species, and new species evolved and that sort of thing. Obviously, in the kind of time frames we're talking about, trees can't adapt or respond in an evolutionary kind of way to changes that are going to occur in their lifetime. One thing they can do, though, is to acclimate. So acclimation is another response, and in common usage we often use adaptation and acclimation interchangeably, but there's a fundamental difference. Acclimation is the response of the individual. So adaptation is the response of a species. And so use a non-plant example here, but we think about acclimation. Those of you that follow sports know about blood doping in cyclists. So what do? They go to high elevation and train. And what does your body do when you train at high elevation? Well, one of the ways your body acclimates to high elevation is to produce more red blood cells. So for a given liter of blood, you have proportionally higher amount of red blood cells. So those cyclists would then take out a pint of their blood, and then they'd put it back in when they were back at low altitude and all of that. But it was an acclimation response that they were looking at. And trees can acclimate too. So we see things like this: sun versus shade leaves, common acclimation response. We know that trees will grow differently if they're planted in shade than if planted in sun. That's a common type of acclimation response. Still the same species, it's still a red maple, right? You plant one in the sun, you plant one in the shade, you get different responses. Those are acclimation responses. So talking about the migration issue first, and this is one that can generate some controversy, and it already has. The idea here is we're talking about assisted colonization or assisted migration. And so if we are saying that, well, we've seen all this evidence from the Intergovernmental Panel on Climate Change, we know temperatures are going to get 4 degrees warmer in the next century, let's just take some trees from the south and move them north. And so if we're looking at something like scenario A, where we have a species, say red maple, this is not the range of red maple, but something that has a very broad geographic distribution. Red maple occurs from Georgia to Maine and up into Michigan and all over. And so if we are moving seed sources of species A and we moved them to the north, is that a very risky move? Well, probably not. I mean, it's a species that already occurs there. Now we're talking about moving a southern genotype to the north, maybe some issues with frost damage and things like this when we do get that odd cold winter. But in terms of, is this likely to become invasive, or what are the other issues might be, you know, not everyone would agree with this 100%, but I think most of us would say that that's something most of us could probably accept and could live with. We have another scenario, which is something like case B, species have a disjunct distribution. So the species occurs here down south in southern population, and it has also a northern area. If we move something from the southern population into this northern area, is that something to be concerned about? Again, probably not. I think most of us would say, you know, this is something, the genetics of this thing is probably already here, and we could probably accept that risk if this is something that's going to enable us to continue to have that tree around, whereas the northern population, it may be beyond now what its tolerances are in terms of heat and drought and so forth. So those are the two scenarios there. The third one, though, gets to be problematic, and we're already seeing some of this, would be we're going to take something from an area where it currently occurs to an area where it doesn't. And for horticulturists, you know, we do this all the time, and we've taken our lumps for it. But certainly for ecologists and foresters and people like that, this is something that is maybe some cause for concern. And this is going on. I'll talk a little bit about this group. This is a group, they call themselves the Toria Guardians. So Toria taxifolia is, I think it's called stinking cedar is the common name for it, but it is a threatened and endangered species in northern Florida. And so this particular group here, the Toria Guardians, has taken it upon themselves to transplant the Toria in areas north of its current range. In fact, they're planting it up in the southern Appalachians. If you lived in the southern Appalachians, is this something you want to see? Well, maybe or maybe not. These people feel like they are, you know, saving the species. Again, it's a threatened and endangered species that if, you know, climate's changing the way they're predicted to, it's not going to be able to survive. And so they name each one, and they're basically saving this thing from extinction is sort of how they're viewing it. Again, you can see where if you were living in this area, especially near a natural area or something like that, that'd be a cause for concern. Or, you know, maybe they're doing a great thing, and you know, maybe the cure for cancer is in this tree somewhere. So there's lots to consider. I'm going to move through a few slides here. I think I'm going to run a little long on my time if I don't. So I'll just mention a few more things. This is kind of a forestry example. Again, thinking about this notion of assisted migration or assisted colonization. In Washington State, foresters out in the Northwest have known for years that trees from certain geographic areas grow well near their geographic origin, and if you move them too far out of the area, oftentimes you'll have less than stellar results. But is this always going to be the case? And maybe what we need to start thinking about is actually looking at these seed zones in terms of climate and start projecting where things are going to be in our future rotation. And this is already being done. The British Columbia Forest Service is working on this, and they're looking at what they're called their assisted migration adaptation trial and actually moving things ahead. So if you look at forestry in British Columbia in the Pacific Northwest, they're often growing trees on 100, 120-year rotation. And so should we be basing our selection on what the climate is today, or should we try to look ahead and base it on that? And so that's really what they're trying to do here, and see if they might be able to get growth gains by doing that. They probably will. There's actually a lot of data on this already from a lot of forestry examples where we collect trees from different seed sources. So the trees, in this case, we're looking at the southern United States, the range of loblolly pine, and we collect seed from these different geographic locations. Okay, so the trees are where we collect the seed from. That's where the plants evolved and have adapted to, and then we plant them out at replicated plantings at all these other locations. So the little stars are the provenance test plantings. And an interesting thing that we find in this, and a fairly consistent thing in these kinds of what we call common garden experiments, where we take trees from different geographic locations and plant them in one spot, or in this case in multiple spots, all the different types at the different locations, is that trees actually grow better when you move them northward. And so a complicated chart here, and I probably should simplify this. This is out of the original paper by Ron Schmidling from several years ago. But the idea here is that if we look at the temperature difference from the location versus where we planted the tree, and we look at the height growth relative to where it was from and where it was planted, okay, if the local seed source were always best, the height of this hump here should go right through 0 and 0. Right? If the local source is the best, then we should be right here at 0 and 0. We should always fall off if we move it. If we move it northward, we should fall off if we move it southward. Okay, but in fact, what we find is just not exactly the opposite. But what we find is, in fact, that trees usually do best, seed sources do best when you move them northward. And in this case, they're saying probably about if you move them up to northward about 3 degrees from their origin. So anyway, so I think there actually is some potential for this, that as we move things northward, they may actually do better. I'll mention just briefly some work we're doing on this. So it's very complex, as you can imagine. We start thinking about what's going on with phenology, also what's going on in terms of physiology. And so we've been looking at this, and what we did is to look at shade trees. So taking, forestry obviously has their own interest in this, but we want to look at trees that we might use as common street trees. Some of this is based on, J. Frank Schmidt provided trees, so some of this is based on what they provided. So if you have any critiques of the species here, this is research, and we're looking at physiological responses. So I know there's some things here that people may object to, but we looked at a red maple, a sugar maple, we had a columnar hornbeam, honey locust, pear, which I know some people have a reaction to, and then swamp white oak. So the first 5 there are named cultivars. The swamp white oak is actually grafted, even though it's not a named cultivar. And so what we did is to grow these trees. We have all the different each group here. We've got all of our 6 cultivars in a row. We have them replicated, and in these greenhouse sections, we grow them at ambient temperature, so our current temperature outside. We ramp it up 5 degrees C, and we ramp it up 10 degrees C. So really looking at kind of a worst case scenario, but thinking about not only climate change projections, but also urban heat island effects. And then we looked at some of their physiological responses. Here you go. Again, we looked at ambient temperature, +5, +10. And we looked at a series of different things. Again, try to think about how might trees acclimate and respond to these changes in their environment. And that's kind of our thesis in all of this work, is what we need to start thinking about and it's very difficult stuff, is what trees are going to be best able to acclimate. So again, thinking about the cyclists going up to altitude, trees doing the same thing. What trees can change their morphology, change their physiology best and most in response to climate change, and sometimes understanding what's the best response can be a bit of a challenge, and that's where physiologists like myself and ecologists are going to have to get our minds around these issues. But we looked at things like net photosynthesis, respiration, leaf thickness, and stomatal density. So stomatal density is how many of these stomates, we're looking at the underside of a leaf, how many of these little pores do we have on the underside of a leaf, and that might be able to help it better acclimate to change. That's just the temperatures, so we were able to maintain the temperatures that we described, and we looked at photosynthetic temperature responses of our trees. And what we're looking at here is, our data didn't quite look this good, but this is the idea, is that if we look at temperature, and this is in Celsius now, for a given tree, there will be an optimum temperature. As we increase temperature, photosynthesis increases to an optimum point. We call that the T-opt, or optimum temperature for photosynthesis. And then as we continue to increase temperature, photosynthesis declines. Okay, respiration increases, we lose carbon. And so that's the general notion. But this is not a static thing. So if we grow trees in a warmer environment, at least some of them will acclimate their response, and we will come up with a warmer optimum temperature for photosynthesis. And so trees that are better able to do this may be better able to withstand changes in increased future temperature. That's kind of what we were after. Not enough time to get into all of the data, and I suspect none of you would really want to, but just some summaries here that I think are interesting. Quercus bicolor, so the swamp white oak. In this case, it actually did show that increase in the optimum temperature for photosynthesis, so had the ability to acclimate that way. But we saw other changes as well. Both the red maple and the honey locust increased stomatal density when we grew them under warmer temperatures. So we grow them under warmer temperatures, they produce these new leaves. When those new leaves come out, they have more stomata on the underside of the leaf. How is that significant? Well, if you have more stomata, you have more potential for transpiration and more potential for transpirational cooling of the leaf. So this, again, is some indication that these trees are able to acclimate their morphology in response to growing under warmer temperatures. The Callery pear and the swamp white oak both had decreased leaf thickness. So we cross-section the leaves, we look at their thickness. How is that significant? Well, if you have a thinner leaf, I probably should have said just produce thinner leaves rather than decreased leaf thickness, but a thinner leaf, if you think of like an air-cooled engine, it's a surface to volume kind of thing, and so a thinner leaf is able to re-radiate heat more efficiently, and again is a potential cooling mechanism. So several instances here where we see some acclimation responses and some indications that these could be trees that are going to be adapted to climate change. That was one phase of the study. We're looking at many of these same cultivars. We had larger versions of the same trees you saw in the greenhouse. We've actually planted in contrasting sites in Detroit. So we have this street side planting, which gets the reflected heat load and all of that. And then we have a park side planting, which is a cooler, presumably less stressful environment. And we're tracking some of the physiology and long-term responses of our trees in that environment as well. And let me take, I think I've got a few minutes here to kind of hopefully, I've thrown a lot in a few, in 45 minutes here, so let me see if I can pull a few things together and see where we go from here. It's clear that, climate in the Midwest and the rest of the U.S. is getting warmer. Certainly we've seen that in the long-term temperature records. We've seen that globally, and we're seeing especially in terms of winter temperatures. Again, with a couple of recent anomalies notwithstanding. When we think about trees in our street sides and urban and community forests, obviously these trees are already living on the edge. We've got urban heat-on effects, we've got restricted heat loads, we've got compaction, we've got de-icing salts, we've got all the things that trees have to deal with in our cities and in our towns. And so that's going to make them even more at risk, and as I say, sort of the canary in the coal mine as we look at this. Several things are likely to become important. Direct temperature effects can impact trees, but I think the bigger impacts are going to be things like phenology, which we're already seeing, and these are very difficult to really predict and try to get a handle on, because what we're talking about are things like earlier bud break actually leading to increased risk of frost injury. Okay, so how do we deal with that? Well, one thing we might look for in some of our future selections is actually later bud break. We do this already. I work with Christmas tree growers, and one of the things we try to avoid is trees that have a tendency to break bud early in the spring. So looking for trees that are going to break bud later and less prone to break bud as soon as things warm up a little bit. So that's one thing we might look at. There probably is some merit in terms of moving species and seed sources northward, but I think we need to be very careful about this. I think a lot of the information that we're seeing come out these days is simply looking at projected temperatures and saying, well, if it's going to be 5 degrees warmer, then we've just moved up hardness zone, and we'll just start planting. If we're zone 5 now, we'd start planting zone 6, and everything is good. But I think we need to be a little careful with some of that, and there's some potential risk in doing that. And at the end of the day, as you might expect, and all of this diversity is really our best risk management tool. And so trying to get a diverse array of trees out there, there is not just one thing that's going to happen with climate change. We're going to get warmer. Some places may get wetter. Some places may get drier. We may see these increases in more frequent. I just saw a report the other day, in fact, that said with climate change they're projecting more of these polar vortex type winters. Well, okay, how do we plan that into the mix? Because again, trees respond to the extremes, not the averages. So that's something we have to be aware of. Let me just take a few minutes. I think if I've got a couple minutes here just to kind of go through. We've been dealing with this here in Michigan, and those of you in the Midwest and the Northeast with the emerald ash borer scenario. So we know that we were putting our eggs in one basket. We had 20+% of our urban canopy devoted to one species, and that species, actually that genus, was gone essentially overnight. And how do we deal with that? And so diversity is really our watchword. One of the things I've done, and as we think about this, is if our climate here in Michigan is going to start to look like Missouri or Oklahoma, maybe look at what they're growing right now and what's working for them, because they certainly have some challenges both in terms of heat but also wintertime cold as well, and so there may be some good selections there that are worthwhile for us. And so for those of you in the upper Midwest, I know we have people from all over on this webinar, but this is the kind of thing you might want to do, is look at some of those projections. Where are those areas and what are those people growing right now? And this was a nice resource. This is a website, or excuse me, a Facebook page, Great Trees for Kansas City, and it's just kind of an open forum. This is dated a little bit. I just left this on here. Currently, they're up to, I think, 300 people or so are on this, and people just put on post photos and talk about their experiences with trees in their area, arborists and urban foresters and whomever, homeowners. What do you see and what do you like? So some of the things they're doing well for them down there that we might think about. In fact, we have this in one of our tests, Pacific Sunset Maple. Again, may cause some heartburn to some people. It's a cross, it's a hybrid, but does have Norway maple as part of the cross. But wonderful fall color and a tough tree. We've got it growing in Detroit, and it's doing quite well. Coffee tree is one that is a good overall urban tree, and certainly has good heat tolerance as well as is adapted to our wintertime conditions. Acer Mayabe, State Street Maple, if you're not familiar with this one, hedge maple, again, one that maybe has a better reputation in some areas than others. I describe the State Street maple as sort of like a hedge maple on steroids, and that may be a good or bad thing, but certainly has good form, good color, and salt tolerance, heat tolerance, something that can be a good selection for a lot of areas. Scarlet oak, actually is a native for a lot of people, and a great fall color right now. Our scarlet oaks around here are looking awesome. Another hybrid that's on the market, things we get into with our urban areas and things like that. We need, limited above ground space, and so columnar-forms are often a nice addition if we can get those. So the Crimson Spire oak is one that's heat tolerant. Bur oak is on most tough trees for tough places. Kind of look certainly character born of age in this particular specimen from KC. And again, red oak, another one. These are ones that we can look at seed sources and maybe try to look at that notion of the assisted migration and starting to move some of these southern seed sources northward, at least incrementally. I don't think you want to start with things from Texas and moving them up to Minnesota or something like that. But I think if we do this in a prudent and incremental fashion, we can have some good results. Bald cypress is an interesting case. This is a species where its geographic range doesn't really tell us everything about it. So it's a southern tree, only comes up to southern Indiana, but does well here in Michigan, and I know it's done well in other parts of the northern U.S. I know Cornell, and even I've heard people say they've got some in Minneapolis. So got knocked back. I've got some at my place. Those 2014, 2015 winters, they were late to bud out, but actually survived and are still doing fine. So that's one that's a good potential choice. Ginkgo, lots of knocks on ginkgo in terms of it's a somewhat of a taxonomic orphan. You're dealing with a monospecific order basically, so it's kind of off by itself on the genetic tree, and so some questions about its value for wildlife and different things, but certainly in terms of a street tough tree and something that can handle salt, heat in urban type conditions, certainly a tree that merits some consideration. So I think I have used up my time, but I don't know, Sylvan, if you can jump on.
Yes.
If we had questions along the way or any comments that people want to pass along.
Yeah, we do have a couple questions here, so let me start asking you those. Hillary Noonan asks, is there any study of roots and their ability to send roots deeper as an acclimation or adaptation strategy? In other words, if particular species are better able to send roots deeper as a way of reaching groundwater. And what
yes, absolutely. And in fact, there's kind of some classic studies done with what are called the lost pines. So if you look at the range of loblolite pine, there's a little portion of the range that sticks off by itself in Texas. So most of it's, of course, the main part of the range is in Georgia, Alabama, Florida, and all of that. But there's a little segment of, and they're called the lost pines, a population of loblolite pine, and kind of a classic study where when you take those trees, you grow them in a common environment with the other loblolite pines. One of the traits of the lost pines, because they grow out in these drier regions, is that's the first thing they do is they send their roots deeper. They have higher percentage of roots to shoot, but also they send their roots deeper. And so absolutely, yep.
Okay. And related to that, I had a question about how carbon dioxide levels might be affecting tree physiology, or is it really more important, is temperature really the driving factor in selecting trees?
It absolutely does. And when you look at the response of, and trying to keep things focused on kind of one thing at a time, but if you look at the response of photosynthesis to carbon dioxide, so if you have photosynthesis on your left axis and carbon dioxide on your right axis, what you see is even at the levels we're at now at 400 parts per million, that curve still rises. And so yeah, absolutely, the change in carbon dioxide itself is going to impact trees. It probably already is. How is something ecologists are still working out. There certainly are suggestions that, as you might expect, plants that tend to be invasive or tend to be weedy are better able to utilize that extra CO2 than trees that are slower growing or less apt to be weedy or invasive. So yeah, those can absolutely impact things. And And so, and then we start talking about the interactions. How is that going to interact with temperature? What will probably happen, and what most people think will happen, and maybe already is happening, is that other factors become limiting. So if you took ecology somewhere along the way, you learned about Liebig's law of the minimum. So plants only grow up to the most limiting factor. And so for a lot of plants, what will probably happen is the next limiting factor is probably going to be either water or nitrogen. So they'll be able to utilize that extra CO2 up to a point, and then after that it's going to sort of stabilize. But if you look at the forestry journals and tree physiology journals, that's really kind of one of the $64 questions right now. Is we know that different species are going to respond differently, and so it's ferreting all that out, and who's going to be the winner and the loser. But I think you can almost guess, and you probably got a pretty good hunch of how that's going to go.
Yeah. Okay, so we have another question here from Toria Antonino in Boston, or in the Boston area, Somerville, and she asks, what would you suggest for street tree plantings? But she's following it up by saying that the problem is that for her is that planners tell the native planting activist group that non-native species survive better and must be planted. They're working on a native-only plant ordinance in their city to preserve native pollinators and increase diversity. And so she'd like to know what suggestions they could give to their city planners.
Well, she's asked the wrong person, because certainly, being against natives is sort of like being against mom and apple pie. But I think when you look at, highly disturbed environments like streetscapes, I'm not familiar with all the native trees in the Northeast. One part of the country I've not spent time. But if you are going to narrow your palette of trees to native only, it's going to be tough. I think of a place like Seattle. If Seattle went to natives only, okay, what do you have left? You've got Douglas fir, western hemlock, western red cedar, big leaf maple. It's going to be tough, and it's very nuanced. I think and I didn't, we can go off on tangents here, but when you look at some of these things, there's lots of information coming out almost daily, and people are starting to talk about things like near natives. For example, Doug Talmy had a paper a while back where they showed that if you look at species that are exotic but in the same genus as your natives, those contribute just as much to biodiversity as the natives. There's studies from Europe where they looked at pollinators, where they looked at what, again, they call they call the near natives, species from similar genera, that pollinators, paid as many visits to the near natives as they did to the natives. So there are some things out there, and ginkgo is, if you've seen Talmy's talk, ginkgo's kind of his whipping boy. And yeah, but ginkgo is off there by itself. It's a taxonomic orphan, and there's really nothing else closely related to it. The other thing is we're often looking at these things from a very narrow perspective. And again, I'll use Talmy as an example. He's looking at it strictly from the perspective of insect herbivory. All right, well, yeah, it's important, what insects are going to feed on things, but trees still contribute lots of values, whether native or exotic, in terms of wildlife cover, habitat, cooling, ecosystem services, all these things. So my view, and maybe not what you want to hear, but I think if you're trying to advocate a native-only mandate, I think you're barking up the wrong tree.
Okay, I think that's a fair enough answer. Let's see. I think it's the same person who's replied that they're not giving up, though, that New York has a 70% native plant ordinance. And
again, I would totally oppose that.
And they are communicating with Dr. Talany, but she is glad to hear about the near natives, too. And I'm thinking that perhaps like the example of the hybrid oak that you gave might be a good example.
Yeah, and again, if you're in these communities, you have to think about, the environment you're planting these things into. And some of this, I think, we have to reason together, and, nurseries, it's a challenge. You know, they'll plant what they're comfortable with and what they know will grow, and sometimes natives can be a challenge. There's lots of native trees that are hard to grow. You have to accept that. You know, around here, you know, try to transplant sassafras. You know, it's tough. Hackberry is tough. There's lots of natives that are tough trees to grow. It doesn't mean we shouldn't try, but you know, there is. Now, you know, the other part of this, and again, I don't want to get too far off in tangents, is we're lumping a lot of things together when we start talking about, you know, native versus exotic. It's a lot of trees, a lot of species that we start lumping in together, and it's you know, we get enough trouble when we do that with people. You know, you start lumping people together, and it gets dicey.
I really appreciate your taking the time to do this webinar today, and I want to thank everyone who's attending as well. Thank Dr. Cregg and the audience for participating.
You're welcome. Good to be here.